Hello and welcome to the Helicopter Safety Kit Learning Factory presentation for EE403 Senior Capstone Design, sponsored by Bell Textron Incorporated. The group members are Miles Green, Amit Gambriewala, Ethan Orr, and Robert Finkelstein. The purpose of this project is to create an add-on safety kit for the Bell 505 multi-purpose helicopter. It serves functions in public safety, medical evacuation, and adventure in a variety of operating conditions. The tail rotor on this aircraft is positioned at a height dangerous to approaching ground personnel, capable of serious bodily harm or even death. Our goal is to reduce injuries associated with the tail rotor by creating a two-part alert and detection system for approaching ground personnel, trained and untrained, in the wide range of operating conditions.
The team placed a large emphasis on the concept generation and selection stages in the project. In order to select a concept out of the many that the team had developed, the team first weighted the criteria against one another to generate weights, as shown in the top left analytical hierarchy process matrix. These weights were then used in two scoring matrices, which allowed the team to rank the concepts based off of how well they satisfied the criteria. The concepts with the greatest weighted total scores formed the final concept. This included a laser time-of-flight sensor package for detection and a combination of an audio and visual cue for the alarm system, although the visual component was unable to be tested.
For our proposed design concept, when it comes to detection, we will be using multiple time-of-flight sensors positioned at multiple angles and elevation. This will allow us to create a larger area of detection and two distinct grids, an inner and outer grid. And depending on which grid has been breached, the system will enter one of two alert states. Sensors will not deactivate the alarm until ground personnel are away from the rotor and out of the grid. When it comes to alert, there are two distinct alert states, initial alert and high alert. Initial alert is triggered when the outer grid has been breached and will last for 30 seconds. High alert will be when the inner grid has been breached and will not be disactivated until the personnel has left the grid. While these alerts are being activated or in play, a high decibel alarm will be blaring over the helicopter's engine and a strobe light will be activated pointed towards the tail rotor.
Our detection subsystem was implemented using a state machine with 5 states, the diagram of which is provided on this slide. The states and the transitions between them indicate the level of danger to the person near the tail rotor and sets the alarm output to the appropriate setting. The diagram on the right shows how the alignment of the sensors creates different regions of detection which correlate to different levels of danger and thus different alarm states. The final image is an example of the Ben Awake TF Mini infrared time-of-flight sensors used to detect objects. These have a history of use in the automotive industry, which is why they were chosen for this project. When this all put together, it creates a system that can reliably detect humans or human-sized objects in the vicinity of the tail rotor, even in the adverse or low visibility conditions you would expect around a helicopter.
This slide shows the alarm subsystem as modeled in NI Multisim. It highlights several key features of our design, such as the input from the Raspberry Pi control module, controlling the 3 NPN transistors, which trigger the 3 outputs to our system. First being the interior LED to the cockpit to notify the flight crew. Second being our exterior features, featuring the 115 decibel siren horn and 12-watt LED strobe lights. These provide auditory and visual cues to alert approaching ground personnel and hopefully avoid any possible injuries.